This is section 6.3.1, Writing Algebraic Expressions and Equations. First, we're going to take a look at 5 steps for solving word problems. You're probably familiar with a lot of these strategies, but it's always good to review. Step 1, read and comprehend the problem. Let x represent one of the quantities in the problem. I cannot emphasize the importance of reading and comprehending the problem. Right? This is probably the most important part to solving a word problem. If you don't understand what it is you're reading, you're not going to be able to solve and answer the question. Step 2, if necessary, write expressions for other unknown quantities in the problem in terms of x. Step 3, write an equation that describes the problem. Step 4, solve the equation and answer the question. And finally, step 5, check your solution by substitution. This is a very important slide because what it shows you is some translations from the English language to what I call the math language, or algebra. So when you're reading a word problem, you want to look out for these common English phrases, and they should trigger you to be able to write your equation with algebra. So for example, if you're looking for what type of phrases indicate addition, we have the sum, more than, and increased by. All 3 of these phrases would indicate to you that you're going to use the operation of addition in an expression or an equation. Next, we have some subtraction phrases. Minus obviously means subtraction. Decreased by, when something decreases, you are subtracting. Subtracted from. Difference. The difference is the answer you get when you subtract. Less than. And fewer. Each of these phrases indicate the use of subtraction. Next, we have multiplication. Times a number. The product of. You'll remember that the product is the answer you get when you multiply. 2/3 of. For example, if you're taking 2/3 of an amount, that means you're multiplying that amount by 2/3. 75% of. So anytime you're using a percentage of something, that's multiplication. Don't forget to change your percents to decimals. Multiplied by, and twice. Twice obviously means multiplied by 2. And finally, we have some phrases that indicate the use of division. Divided by, the quotient, because the quotient is the answer you get when you divide, and the reciprocal of. So when you're reading word problems, look out for these common phrases. They will indicate to you what math operations to use in your expressions or your equations. All right, so let's put some of those phrases to practice here. So we have some English sentences, and we're going to write the algebraic expression. So number 1, it says the sum of a number and 7. Well, the sum indicates addition. Of a number, well, they're not telling us what number to use, so it could be any number. Therefore, we're going to represent that with our variable x. What are we adding to x? 7. So we come up with the expression x plus 7. Number 2, 5 more than a number. Well, if we have 5 more than, that means that we're adding. So more than means adding on to. 5 more than a number, well, they don't tell us what number, so that's going to be x. And since we have 5 more than x, that's x plus 5. A number subtracted from 8. Okay, a number, well, they don't tell us what number, so that's going to be our variable x. Subtracted from 8. Anytime we're subtracting from 8, we have 8 minus. So in this case, we have 8 minus x. Number 4, the difference between 6 and a number. The difference is the answer you get when you subtract. So we will be using subtraction. What will we be subtracting? 6 and a number. So that gives us 6 minus x. Next we have the product of 3 and a number. Remember that the product is the answer you get when you multiply. So we're going to multiply 3 and a number. What number? We don't know. So we're going to multiply 3 and x to get 3x. 75% of a number. Well, recall that 75% of anything means we're multiplying by 0.75. What are we multiplying 0.75 by? Some number. Since we don't know what number it is, we use x. So we have 0.75x. A number divided by 3, well, obviously we're dividing. A number will be x, and we're dividing x by 3. So we have x over 3. And finally, the quotient of a number and 7. You'll recall that the quotient is the answer you get when you divide, and you are dividing a number and 7. So we have x over 7. So there's some good examples of translating English into algebraic expressions. All right, now let's put that practice to use in a word problem. As athletes find ways to safely and legally improve physical performance, we have witnessed the record for the fastest mile drop over the past century. In 1923, the mile record stood at 4 minutes 10 seconds, 10.4 seconds. In 1954, Roger Bannister of Great Britain broke the 4-minute mark with a time of 3 minutes, 59.4 seconds. Since then, the mile record has fallen by about 0.3 seconds per year. If this trend continues, when will someone run a 3-minute mile? All right, so we've read the problem. It's important that you comprehend what you've just read. Some important information. They do give us the information about the record back in 1923, but that's not really going to help us because they don't tell us anything about that mark after 1923. What they do tell us is that in 1954, Roger Bannister ran 3 minutes, 59.4 seconds, and that since then, the record continues to fall. If something's falling, it's going down, it's being subtracted by 0.3 seconds per year. So if this trend continues, when will someone run a 3-minute mile? So 3-minute mile is what we're looking for. All right, so one thing that we have to take into account here is the units that we're going to be dealing in. We're obviously working in time. We have Bannister's time, we have the time that the record is decreasing by, and we have time for a 3-minute mile. But we can't work in some minutes and some seconds. They have to all be the same. So we need to decide that everything that we put into our equation is going to be in terms of seconds. So we're going to start by converting 3 minutes, 59.4 seconds into seconds only. So we know that there's 60 seconds in a minute, and we have 3 minutes, so that's going to be 180 seconds. But we have to add on the 59.4 seconds, so we end up with 0.4, 9, 8 and 5 is 13, carry the 1, 2. 239.4 seconds was Roger Bannister's record. Now they're telling us in the problem that that record is decreasing by about 0.3 seconds per year. So we have 239.4 decreasing by 0.3 seconds per year. Now we don't know how many years it will take to get to this 3-minute mile mark, So we're going to plug in x representing the number of years, and we want this algebraic expression to equal 3 minutes for the 3-minute mile, but of course 3 minutes is way back here 180 seconds, so we want this to equal 180 seconds. So now we have an equation that we can solve for x, and remember x stands for the number of years. So let's do some simple algebra here. We're going to subtract 239.4 from both sides of the equation. So that will eliminate it on the left side and leave us with negative 0.3x equals negative 59.4 on the right. Now we can divide both sides by negative 0.3. This cancels out on the left, leaving us with just x. And we can use our calculator to calculate negative 59.4 divided by negative 0.3. And we come up with 198. Remember that x stood for years, so this is 198 years. But remember, Bannister's record was set way back in 1954, right there. So, based on our equation, 198 years after 1954, that'll give us the year 2152. That we could expect that if this trend continues, somebody to run a 3-minute mile. So just to recap, remember to implement these 5 steps for solving word problems. Read the problem carefully, comprehend it, write an expression in terms of x, write an equation that describes the problem, solve the equation, and check your answer. This has been section 6.3.1, Writing Algebraic Expressions and Equations.